We're live. So this coffee cup was a gift when I finished my PhD in some rock science thing.
Right.
Someone gave me a cup that says "You rock." Pretty cool.
Yeah.
I see we've got some show notes together at the last minute. Your notes are much more extensive than mine. So,
It's nothing like just-in-time show noting.
That's right. We're on episode 14, so welcome everyone to Undersampled Radio. Matt, what's going on?
Yeah, you know, it's I'm sort of just getting back in the swing of things after a couple of weeks away still. And you know, just getting into my day. I'm in my back in the hub, back in my usual seat. How's things with you? Are you busy?
Finally busy. Yeah, it's nice working on a couple of different little side projects, but I actually am working now, which is lovely.
That's cool.
I'm doing an AVO density inversion for a client, and it's kind of neat. I'm writing the entire thing in Julia, which I haven't done yet. So it's always, and the same thing goes with Python. So by the way, I may have said this before. We may have mentioned this, but last year Matt and I were having a conversation. And it sounded to me like he was a huge fanboy of Python. And I said, just to be contrarian, I said, Matt, Python sucks. And he said, no, it doesn't. What's better? And I said, Julia's better. And ever since then, I've been trying to spite him with my Julia nonsense. So anyway, I'm writing an inversion.
Spite or smite?
Yeah, that's right.
And so you haven't changed your opinion then? Clearly, you're still going down the Julia road.
Well, you know, honestly, Python it really is wonderful. But I'll never admit that to you.
Oh no. Okay.
I actually do a lot of work on Python.
Yeah, it's a handy language. I've left it behind though myself.
No.
No, I haven't left it behind. But I am learning another language. I've started learning Lua.
I have no idea. Tell us a bit about it.
Well, I don't really know all that much. So I'll keep it short.
You're gonna keep it to Hello World?
Yeah, basically. Well, the cool thing is the Hello World is exactly like Python's Hello World. So I first became aware of Lua probably 3 years ago, something like that, when the MediaWiki project adopted it as its scripting language. So MediaWiki is written in PHP, so this is the software that runs Wikipedia and other wikis. So it's written in PHP, and what you used to have to do to make anything kind of cool happen, if you wanted to sort of have a page make a decision about itself, like sort of say, what's a good example? Well, so wikis are really strange things, right? So they're actually these sort of living, breathing, almost organic things. So what some of the parameters for wikis live in wiki pages, right? So you can actually set some of the parameters for a wiki by editing a wiki page, and then another wiki page reads that page to decide what to do about something. So it's a really kind of cool concept, and that it sort of permeates the wiki way, as it were. And you wouldn't notice it if you were just reading a wiki, because these are all on sort of weird hidden pages in obscure namespaces and so on. But anyway, the scripting previously was really clunky because it was all essentially written like right in the wiki, and you had these things called templates that could have these dynamic components and do things like an if-then, but you ended up with these extremely clunky, like the syntax was just horrendous. It was very clunky indeed. So a few years ago they adopted Lua as a real scripting language, and the thing about Lua is it's embeddable. it's very easy to embed it into other things. So it's very easy to embed it into, say, the wiki, I guess a little bit like, a little bit like JavaScript, I suppose, but it's still running on the server. It's not running in the browser. So they didn't want to go down the kind of JavaScript road. So keep control of the code. Make sure that you're only running your own stuff, and but it's really expressive language, just like Python. Dynamically typed, really good at handling strings, really good at handling giant strings, and sort of, it's a very lightweight language, so it's great for these big data structures. Anyway, sorry, I said I'd keep it short, and of course I'm not. Then I sort of ignored it for a while, and it popped up again at the hackathon a couple of weekends ago. I picked up the project that I started when I met you at the New Orleans hackathon, which was a silly machine learning project, because that was we had a machine learning theme at that hackathon, and I was trying to train a model and produce random sentences about geophysics, or random paper titles, if you will. And I finally got to finish that project, and the best neural network code I could find was written in Lua. And so the one of the sort of handful of major packages for neural networks that's sort of come to the fore in the last few months, really, alongside Google's huge TensorFlow project, which has a really good Python interface, is something called Torch, which is a Lua project. So so I was sort of wielding Lua again. And that spurred me to sort of try and learn a little bit about it, so I can read these scripts better and fiddle with them. Anyway, sorry, there you go. So there you go. Lua, pick it up. It's free. It's Python-y. There's a good tutorial on the Lua website.
There you go. There's a short description from Matt.
I'm sorry.
So I would mention that the things I like, I came up as a C programmer, so moving into the Python, Julia world, it's still incredible to me how easy it is to do things. And so how accessible is Lua to a beginner?
I'd say if you know any Python at all, it's going to be super accessible. I'm not sure if it's one of those things where it's like so close that it might be hard to keep them separate in your mind. So it feels very familiar. And I gather some of those patterns were picked up even from C. I mean, I don't know enough other languages to sort of know where the similarities are, but so far I'm finding it much more, much sort of easier to grasp than, say, JavaScript, which is the only other thing that I use regularly. Yeah, I know, exactly. Thumbs down. Yeah, I mean, I struggle, like, when people sort of say, hey, you know, I want to learn a programming language, what should I learn? Like, somehow, I mean, obviously my first answer is Python, but...
Obviously.
Yeah, you know, just with that my level of comfort with it, and I know how flexible it is to all sorts of different problems. But I have a slightly hard time not, like, leaving JavaScript out of recommended languages. Like, it's pretty cool what you can do in a web browser, and there's so many resources out there for people who want to pick up JavaScript and do interesting, fun things for other people on the web. I mean,
yeah, it's tangible.
Yeah, there you go. And I have heard, so something I haven't really been paying attention to is sort of JavaScript. I mean, it seems like such a kind of chaotic language and community that I almost sort of can't believe that anyone's actually thinking about its future and a roadmap, because it just seems like you can do whatever you want already. But apparently it does have a roadmap, and there are release cycles for the specification of JavaScript. And Java. So, what can you remember the name of? I I'm not remembering the name of the specification or whatever you want to call it. Anyway, it's in its 6th iteration, and because it's not called JavaScript 6.
Oh, I have no idea.
Anyway, it'll come back to me in a second. Anyway, apparently there are some new things in the sort of latest iteration of JavaScript that are particularly good for numerics. ECMA, I guess, is the I don't really understand that whole world, but ECMA 6 is or ECMAScript 6 is the thing. So, because that's one of the things you notice right away if you're used to wielding arrays and doing vector and matrix math, is that JavaScript is just not good at stuff like that. You can't easily read a column out of an array of arrays. You have to use a loop. So, if that stuff changed, it would be very tempting to do all sorts of geophysics in JavaScript.
Yes, true.
As it stands, you need some sort of back end that does numerics, and you're passing JSON around, and it's all a bit clunky.
Which presumably is Python.
Yeah, our back end's a Python, but yeah, whatever. Has anyone written a web server in Julia yet?
Yeah,
probably.
Someone has.
Yeah.
But I'm not allowed to talk about it.
Oh, okay.
Hey, tell us about the hackathon.
Yeah, so the hackathon was awesome. I mean, the hackathons are a funny experience for me because they're not stress-free to organize. I write a lot of begging emails to people I don't know, and one thing about this go around was because I was writing to a bunch of, it's mostly professors but also professionals in Europe where I don't have the same kind of network I have in the US and Canada. The level of kind of response I got was much lower than usual. I didn't count, but I bet I heard back from fewer than about 25% of the people that I wrote to. So I'm writing to these sort of random professors at IFP and places like that, and I don't know. I find that demoralizing, I guess. It'd be nice just to get a thing back saying, I don't know who you are, I don't know what this is, go away. I'd rather get that than just sort of nothing. But so I really had even less idea going into it, like how much reach I'd had, how many people had even heard about it. Because one of the things we always get, at least afterwards, is like, oh, that sounds really cool. If I'd known about it, I'd totally have come. So I do try and like spread them out there. But that takes time and effort and resources, and those things are always in short supply. So I didn't really know what I was walking into. We had like 20 or so registered. I think we had 17 people actually show up, so it was enough for 4 teams, which is great. Like I think we've had 4 teams, or 4 to 6 at all of the hackathons. So that's been. So maybe that was in line with what I should have expected. I was secretly hoping for more than 20 people, but but once you get into the event, it's amazing, right? It's a fantastic experience to gather mostly strangers together, students, several MSc students, mostly from Leeds actually. Leeds sent a big contingent, which was great. Master's students, so not experienced people. A couple of them hadn't really coded at all before, all the way through to, I think we had the most professional coders we've ever had show up. So 5 guys drove on a sort of road trip from Freiburg in Germany, 6 hours. A little team of guys from a small consulting firm in Germany showed up. Plus we had a guy from Rockstar and the awesome Steve Purvis, who's on Software Underground, came from Tenerife. So that was so. What's so cool is these strangers come together, and there's a team with like a master's student, a professional developer, a PhD student, working on some tangible, real project for 2 days. So I love that kind of deep connection that comes out of these sort of events. And once people get in the coding zone, that's really cool too. And it's, the students always bring a level of kind of just really inspiring enthusiasm. You know, there's like high fives and whoops, and it just sort of really, it's really awesome to see. Like, in many cases, people who knew each other but had never worked on a project together, you know, too. So anyway, so once you get into that, it's just fantastic to be a part of it.
Yeah,
so,
I can agree there. The one I attended last year was amazing, and if anyone listening has a chance to come to another hackathon, I totally recommend it. It's worth spending the extra money to come early and get a hotel and hang out. It's great fun. Are we ready to talk about the SEG this year yet, or not?
yeah, I don't know. I mean, I'm happy to.
It sounds like no. Maybe we should wait until another show.
I don't know. I mean, I guess on some level, I'd really like some kind of feedback. So if listeners and people on Software Underground want to like jump in with feedback, I guess I'm looking for a little bit of encouragement because I feel a bit hesitant about doing another fairly low-key thing for a small number of people. We've been talking about trying to do something more audacious, for example, in the exhibition, and what that made me think is, okay, well, if we can be highly visible, but also therefore more, because we'll be during the actual conference, I wouldn't expect people to sort of show up with, you know, solid chunks of time. It would be more likely a couple of hours here and there. So we'd need to come up with something which is easier to jump in and out of, but also can involve a great number of people. Like, can we make 1,000-person hackathon? You know,
right?
That could be a really fun challenge. So I've got an idea about what to build that around, but I feel like it's going to take more than just that idea. And of course, it would take a substantial amount of sponsorship. If we're going to do something during the exhibition, that means being in a booth and you know, just having access to some resources. So anyway, it's a bit up in the air. I guess we're in the ideation stage, and I'm happy for people to jump in and contribute in any way they want. How's that?
What's your idea?
So the idea is to essentially challenge the community to reproduce favorite and famous figures from papers in geophysics, leading edge, and the literature in general. So basically to write code snippets to check into a giant repo in GitHub that reproduce these figures. So that means potentially harvesting data from public sources and or from the papers themselves. So for example, digitizing crossplots, that kind of thing. It means turning the published equations and algorithms into actual working code, maybe even in multiple languages. I'm really into this concept of chrestomorphies. I can't remember if I talked about those. I think I did mention them before. So repeating the same problem in multiple languages. And just, yeah, sort of saying, look, we can take these resources and make them an order of magnitude more useful by coding them and not just leaving them as a giant pile of equations for other people to go away and implement on their own, right? And potentially have 50 implementations of these things floating around, some of which may have serious bugs in them, and you know, instead let's do it together and do it in public. So but I can imagine people showing up with like a paper saying, hey, I really want to like code up this paper, or others saying, oh, I've written a paper that I'll share the code for, or just, you know, here's like, I really like the concept of this whatever elastic impedance implementation, but I think there's a much better visualization of the result, you know, so people who aren't necessarily coders can even contribute ideas around data visualization and sort of conceptual mashups. You know, what if you take this equation and make it frequency dependent, and this kind of thing. So
yeah.
I think that could be really good fun. It would be obviously a whole new set of unknowns to tackle, and lots of other complexities around being part of the conference and so on. But yeah, that's the idea.
Well, it sounds like you're going to need some whiteboard sponsors.
yeah, definitely.
Oh, well, that's cool. We'll keep everyone up to date on the Software Underground as ideas develop, and as Matt says, he encourages feedback and contribution to the brainstorm that is the beginning of this semi-public hackathon weirdness.
The idea is completely open. I'm looking for contributors and helpers. And do you want to just remind people, Software Underground, how to get in there?
Oh, swung.rocks, http://swung.rocks. Check it out. I want to mention, since we're talking about open code for folks to just go have, I wrote the middle of this project that I'm working on. I needed some standalone compression tools. I may have mentioned this before, but in case I didn't, it's discrete cosine transform compression, standard stuff. It's used in everything, JPEG and all these things, and it works on its own, right? So these are seismic Unix tools that I've built into a standalone lib, and you can find them on my GitHub if you want them. So there's a compression tool and a decompression tool, and they work great. It's kind of nice just to have, a little seismic compressor just sitting around in case you need to email some seismic panel or upload something smaller to Dropbox or whatever. So go check them out if you want.
So is that, I don't know a lot about, yeah, sorry.
He's raising his hand, by the way.
It's funny because
two of us on this call, and he's raising his hand to talk.
No, but the really stupid thing is that I thought, okay, well, this is a podcast, so no one can see me if
so you thought I wasn't going to call you out.
And so A, thanks for drawing attention to it. But B, I forgot that we're also recording these on Hangouts on Air, so people, if they tuned in, could actually see me, so the whole thing just went horribly wrong. Anyway, now that I've got your attention, is this lossy compression like JPEG then? It
is, and you can tune the level of loss based on whatever threshold requirement you have to a limit, obviously, and you can play with the parameters a little bit to try to adjust your compression ratios and things like that. It's a really simple tool, just quantization, just transform, quantization, run length encoding, and zip it up. So it works nicely. It's not the most effective compression you'll get, but again, it's free and it's there. So if you want it, check it out.
Sorry, I have another question. So in JPEG lossy compression, there are 64 pixel squares, so 8 by 8 squares that the compressor sort of, if you like, can bleed information across. Does your implementation handle the compression on a trace-by-trace basis, or can energy leak from one trace into another one, if you see what I mean? Is it voxel-based or trace-based?
It is voxel-based, and you can tune the size of the voxel blocks as you see fit.
I see. Interesting.
Yeah, okay. If you were a little bit clever about it, I think you could implement it almost as like a video compressor. If you lined up your 3D data with your third dimension kind of trailing back in time or something, so line it, compress in a loop. So that would be like a 2.5D compression. It's written as a 2D compressor on a panel.
Yeah, I see. That's an interesting idea. Oh, has anyone tried that? Do you know, for like MPEG style encoding of seismic?
Yeah, it's again, 3D image, video, whatever you want to call it. There are 3D compressors like that specifically built for seismic. Actually, there was a good one written by some guys at Chevron in the late 90s, and I got in touch just to see what their idea was. But they filed a patent which is now expired, and you can, if you read the patent, you can actually get a pretty good idea of what the algorithm was. So I'll look it up after this and put a note in the show notes.
Yeah. So Landmark had their bricked format, which did 3D lossy compression, and I don't know how much is known publicly about that algorithm, but we thought it was kind of an interesting approach, and had decent fidelity. You know, you could get quite a bit of compression without losing a lot of fidelity. But what I was going to say, I guess, about the MPEG idea was that actually in video frames, the sort of assumption is that there are large parts of the frame which don't change from one frame to the next. But you can't make that assumption with seismic, because actually you know that every time slice is different because it's band limited. Right, so
well, I think that you can make some assumptions like that, and in fact, I would claim that you can make larger assumptions because the data is periodic. Now we're moving away from the realm
we
of
can make different assumptions, I guess, about the periodicity, and surely exploit that.
But run length encoding still works across. If you were talking, for example, about stack data, there's some symmetry between spatial slices, because I mean, if you're in complex structural geology regions, there's a high degree of incoherence in the data. But if you're in, say, a pancake geology setting, you can be really very effective with your run length encoding across spatial slices. You know what I mean?
Is this what's the bit depth of the data that you're compressing?
The algorithm that's on my GitHub is 32.
Oh,
and it's full
floating point
accuracy. But
you must quantize
an obvious
length encoding.
Yes, yeah, of course. But then the obvious first step is to chop it, just stick it into 8 bits. I actually can't remember, but I think you may be able to do that as an input. So,
I see.
Anyway, there you go.
Yeah,
so
cool.
we've covered 2 bullets, and we've got like 17 bullets here in the notes. So Matt, pick your favorite bullet, and we'll each do one more and cut it off.
Yeah. Well, okay. There's one's very short that I'll just mention really quickly.
Okay, then you get 2. You get 2 bullets.
Yeah. Sorry. So there's a special issue of The Leading Edge next March. So March 2017 is going to be on. I think they're using. I'm just trying to remember which buzz phrase they're using. I think it's data analytics. So in other words, there's a machine learning special issue, March 2017. The associate editors are looking for paper proposals right now. I stupidly didn't write down the guy's name, but it'll be in. I'll put a link to the editorial calendar for The Leading Edge in the show notes. How's that? And that'll tell you who to get in touch with. But they're looking for papers in about November. Now, I know that that's well ahead of when the editorial deadline is, so there's probably a little bit of flexibility around what November means, but that's the kind of time frame. If you would like to contribute to that issue, I think it'll be a really good one, so I definitely will be. And I think we're going to also do a special tutorial for that issue. So we don't normally run a tutorial in March. I haven't really given that a lot of thought, but if anyone's got a burning desire to write a short tutorial about some machine learning topic, that would be greatly appreciated. And that leads me nicely into sort of a segue. It's not really a segue. Now it isn't a segue because I've derailed it. Anyway, so after the hackathon, so a couple of Mondays ago, was the EAGE open source workshop. So this is a somewhat regular event in that every 4 years or so, they add this workshop. I was at the last one in Copenhagen, and the one before that I think was in 2006, also in Vienna. So it's kind of a regular get-together for the open source geoscience community, and when I say geoscience, I mean geophysics. And when I say geophysics, I mean seismic modeling and inversion, because that's kind of what it ends up being about. But I must say there were definitely more people there this time than there were last time, which was kind of surprising given that EAGE itself was a little bit of a underattended, a bit of a downer actually. So I'd say there were at least 120, 140 people in the room, which is a pretty good turnout for something about open source software. You know, on the one hand, it's kind of the usual suspects, so Sergei Fomel talking about Madagascar, Christopher Tingdahl from DGB talking about OpenDetect, me banging on about you know, open source community activities. There was also, what they always do quite a good job of, and the sort of the best bit of the whole day actually, is the sort of, it's not really lightning talks, but shorter talks that just sort of kind of bang through a bunch of new projects. So I documented these on the blog. It's right now, well, the post was on the 1st of June. It's called Open Source Geoscience is blank. So you can go find that if you want to kind of read about all the projects. The couple of highlights, there was a geological basin modeling project, which, well, not truly open source because it's built on MATLAB, so it's built on proprietary technology, but maybe it would run or could be adapted to run on GNU Octave, which is an open source implementation of MATLAB. So that was really cool just to see a geologist talking and a woman talking, and a cool project. Just basically taking well data and building 3D basin models and modeling things like compaction, burial rates, and so on. So that was really nice, and some cool visualizations too in the package that she's built. And then there were, like, I think at least I counted 5 FWI packages. So that's pretty hot. 2 of them written in Julia, 3 of them in Python. So these are out of various places, MIT, where else? Edmonton, a couple of other places, I can't remember, they're all on the blog. So those are sort of, so that was remarkable, I guess, but the packages themselves I can't say much about. I don't know a great deal about them. And actually, one of the patterns that I sort of mentioned in the blog was a little bit of frustration around this sort of, I mean, I guess these are consortiums, so I understand why consortiums exist. They're a good way of funding academic research. But frustratingly, the consortiums seem to be sort of building an open framework, and then there are private or proprietary or secret add-ons and plugins that actually implement all the cool things that the consortium wants to do. And I guess I understand why that happens, and I think maybe that's fine to keep them secret for a while. I think, you know, at least in Canada, many of these universities are publicly funded. Professors are paid out of public money, at least partly. They're certainly using publicly funded resources. In a way, they're like kind of turning into software development shops. Some of these consortiums, they've basically got grad students writing code that the grad student will never be able to use again once they've finished, because it's locked away in Shell and Schlumberger and the other sponsors of these consortiums, and it's just a bit weird. So you know, that came out in the workshop. There were a couple of slots for discussion. You know, Schlumberger, a guy from Schlumberger stood up and said, at Schlumberger, our favorite consortiums are the ones that have proprietary code, like where we basically purchase the code essentially, and it never sees the light of day. Like that's the sort of consortium we want. I was just like, okay, great.
Would you care to burn some bridges here and mention some of these consortiums?
Well, he was just talking in very general terms about, you know, well, I mean, take. one of the ones that frustrates me is SEAM, which is an SEG consortium. The SEG is a member of the consortium, and yet the SEAM models are private to the consortium for long periods of time. So I believe the original SEAM model is now open, but the SEAM 2 model is not. It's only accessible to the consortium members, even though SEG is a member of the consortium. Well, sorry, that's not quite true. Even though SEG essentially maintains the consortium in a way, or hosts it. Actually, so one of my recommendations to SEG was that it becomes a member. Essentially, it signs up the membership for the $40,000 a year, or however much it is to join this consortium. There are 40,000 members of SEG, so it's like $1 a year per member, and then we all get access too. But I guess one of the things that riles me a little bit is that the language around, and the seismic apparition guys from ETH and Statoil used this language. The chap that talked after them also used this language, where they're like, we want to progress geophysics. We wanted to put this algorithm or this method out there into the community to make geophysics better. We want people to get better at whatever it is, simultaneous source acquisition in their case. And yet it's all encumbered by patents, all of it's protected, all of it's proprietary. We're not actually giving away any, there's certainly no code. We're not even telling you the details of the implementation that we're using. I mean, I asked one guy from a university in Brazil that I can't quite remember the name of, in Rio. He'd done some work for Petrobras, essentially programming work for hire, as far as I can tell. He wouldn't even say what language the stuff he'd done was written in, or what machine learning libraries he was using, right? I'm just like, why even tell the community about this? It's kind of like, it would be like buying a cookbook and all it has in it is pictures of the food that someone's made. It's just like, what's the point? I get that everyone's doing cool stuff. That's great. But if there's nothing I can do about it, then just keep it to yourself, because it's just of no use to me or anybody else, or the community in general. It's not progressing geophysics. You're not putting things out there. You're doing your own thing in your own corner. Don't call it anything else. And if that's what people want to do, and if that's how people make a buck, awesome. But don't come to scientific conferences and share it in a scientific paper like it's progress, like it's even science. I can't check your work. It's not reproducible. It's not science. Sorry. It's basically a weird kind of advert. So anyway, sorry.
Nice place to advertise.
Yeah, I mean, okay. So just a tidbit about SEG, and this is hearsay.
Let's have another rant, please.
No. So apparently this year there were more. So I remarked to somebody, EAGE, wow, this is probably the smallest EAGE's been for years, and there's still 15 parallel tracks of talks, right? That spread over a distance of like 1.5 kilometers between each other. I mean, it's crazy. And some of the talks, I went to a couple of SPE talks, and there were literally sort of 9 people in the room. You could have had a Google Hangout, and it would have been a more effective way of sharing the content. And and I said, wow, that's kind of weird. And someone said, well, actually, SEG this year had a record number of submissions. Which I was like, oh, wow, that's kind of surprising, because a lot of people I've talked to have said, I'm not going to conferences, can't travel right now, there's a total ban on everything. But I guess it's like this, it's the only way to go to SEG now, is to have your abstract accepted, and at least you've got a shot, right?
That's right. Additionally, or alternatively, you could come exhibit your ideas on the Undersampled Radio.
Oh yeah,
because you'd still get 9 people listening to you. Okay, yeah. So occasionally while we're doing this, I'll time Matt's rants.
Oh, God.
And in fact, what was supposed to be Matt's 1 bullet point before my 1 bullet point turned into Matt's 7 bullet points, and I'm going to save my last bullet point for next time.
Oh, what? Why? What? How long have we been? How long have we been going?
Long enough to put everybody that was listening asleep.
Oh, I'm sorry.
So thanks for listening in, everyone. We will see you next time with somebody. We're gonna have a guest. I don't promise, but I hope that we're gonna have an awesome guest for you next show. Matt, see you later.
Cool. Yeah. Take it easy, man.